Alright, so tangent graphs is the second part of 11.1. I basically split it up just because, I don't know, this is kind of a different monster. It's not that it's that hard. It's just totally, well, it's totally different pretty much. So amplitude and period is pretty much handled the same way with this, except amplitude for tangent is a little different. But now we're going to introduce asymptotes, but it's not going to be as hard as you think it is because I'm going to try to show you the easiest way I can. So tangent, we find our amplitude and period the same way, except amplitude for tangent is undefined. So you're not going to have to worry about creating like two horizontal lines and your graph stay in between that. It's not going to work that way. Instead, we're going to use asymptotes, which I'll show you how to find that. But our period is found the exact same way. It is pi. Well, actually, it's a little different. Instead of it being 2 pi over b, it's just pi over b. So that's what we have here, pi over absolute value of b. So if we just look at tangent of theta, there's an understood 1 to be right in front of this theta, so that means that we would just have pi over 1, which is pi. So there's another part to this, which I just said, are the asymptotes. Now the asymptotes are odd multiples of pi over 2 times b. So essentially, once you find the period, you can divide that by 2 and it'll be the same thing. So here's the odd part, is the way that it's phrased here. I don't know, pretty much when they're multiples of like pi, you would say like pi, 2 pi, negative 2 pi. If it were multiples of like pi over 2, you would say pi over 2, 3 pi over 2. Anything that had like the denominator 2 would be a multiple there. So I don't know, don't get too confused on that, or try not to. It's not as complicated as it sounds. So I'm going to graph just this one first just to show you. So tangent of theta, we would have our start point at the origin. But first, what I like to do is graph my asymptotes. So my asymptotes for this would be, and usually I always make myself like another little column and say like asymptotes. They would be pi over 2, because if we take the period, or if we take b here, it would just still be pi over 2. So that means that at pi over 2, I'm going to have a vertical asymptote. At 3 pi over 2, I'm going to have a vertical asymptote. At negative pi over 2, I'm going to have an asymptote. And at 3 pi over 2, I'm going to have an asymptote. So that means each of these graphs has to be in between these, just like that. So first of all, you want to start at your origin. And you want to take this pi over 2, this amplitude, and you want to split that in half. So if I split pi over 2 in half, it's pi over 4. So that means that when x, or that means when I'm making 2 points for this, I'm going to have a point at, I guess it would be up 1 and over 2 pi over 1/4, and it would be down 1 and over 2 pi over 1/4. So it would be right here. So then my graph is going to look like this. And I'm going to do that for each one of these. So essentially, I'll have a point here in the middle, and that would have one there, there. I would go up here. So essentially, you use that period kind of as your start point, and then your amplitude, or your asymptote split in half, you use that for 2 points to use as your little guides. And you really just go up and to the right one, wherever that point would be, or it may be like to the right a couple, depending on what your half of your asymptote is. And then you go down and you do the same thing. So when you're moving on the y-axis, you're just going up 1 and down 1. But on the x-axis, since it's in like pi over 2, pi, since the conversion's a little different, it may depend on how you do that. But we'll look at that when we do different ones. So then if we come back over here and do the left side, we would start at negative pi, because that's kind of our period. That's kind of like our start point. Then we would go, the asymptote is pi over 4 when it's split in half. So if we split this in half, it's pi over 4. So we're going to go up and over to pi over 4, or I guess pi over 4 units. And then we're going to do the same thing when we go down. Because like this point here, I think would be 3 over 4 or 3 pi over 4. And this point would be pi, it'd be 4, no, what would it be? It'd be 5 pi over 4, I think, maybe. But either way, it doesn't really matter as long as they all look the same, just like this. So that's what our original one looks like. Now we'll look at some different problems. So if we look at number 1, we have 2 times tangent theta. So first of all, the amplitude is undefined here, but our period is going to be a little bit different. It's going to be, well, actually, no, it wouldn't. It would still be pi, because we would take b, which is understood to be 1 in front of this theta, and we would say pi over 1. Then if we want our asymptote, so I always like making a separate column for my asymptote. If we want the asymptote, it's just taking this and dividing it by 2. So it'd be pi over 2. So that means at pi over 2, I'm going to have an asymptote. At 3 pi over 2, I'm going to have an asymptote. Basically, once you get that fraction, anything with a denominator 2, there's going to be an asymptote there. All right, so now we're going to divide our asymptote into half again, and that'll give us kind of our points we need for this. Now, the only thing that changed here is this 2 kind of changes things a little bit for us. It just means that instead of going, so when we did tangent, we started out here. When we just had tangent of theta, we started out here, and we went pretty much up 1 and over 1 and down 1 and over 1 there. Now, instead of doing that, so we still want to go over to pi over 4, which would be here, which would be somewhere on that line and somewhere on this line. But instead of going up 1, now we're going to go up 2. So we're going to go all the way up here and then all the way down here. Actually, yeah. So then our graph's going to look like this. Let's do that again. So then our graph's going to look like that. So this part is the part that's confusing, knowing when to do that. But the best thing I can tell you is just pay attention to your original one. We only went up 1 and over 1 essentially, or on the y-axis we went up 1 and down 1. Here, this 2 in front multiplied just changes our dimensions a little bit to where we're going up 2 and then over to pi over 4 technically. All right, then we're creating our other 2. We would essentially start at pi, and then we would want to go up 2 and over 1, because over 1 unit here would be pi over 4, or actually it would be pi over 4 units away from this pi. So it would be, I guess, pi and 1/4. And then we would go down 2 and then go over 1/4 unit again, which would put us right here. So now we would have something like that. And then the last one, we'd start at pi again. Actually, it'd be negative pi. We would go up 2 and over 1/4 of a unit. Then we would go down 2 and over 1/4 of a unit. And that would be right about there. So that's what our graph would look like. Now, I'll show you number 2 and 3. So let's go look at those. So 2, we've got tangent 1 over 3 of theta, or tangent 1 over 1/3 theta. And our amplitude here, since it's tangent, our amplitude is undefined, so we don't have to worry about making like 2 horizontal lines. But we do need our period, which is taking b, which is this 1 over 3. And we're doing pi divided by 1 over 3, which will end up giving us 3 pi, because we flip this fraction and multiply. So the period is 3 pi. Now our asymptote is just taking that and dividing it, taking this period and dividing it by 2. So that'd be 3 pi over 2 would be our asymptote. So anywhere we see 3 pi over 2, there's going to be a vertical asymptote there. And for the size of this, we really only need those two because we can't really fit anything else in here. All right, so tangent's going to start at the origin. Now, in order to find our 2 points we need kind of as our guides, we're going to take 3 pi over 2, and we're going to divide that entire thing by 2. So then what would end up happening is we would get, let's see, 3 pi over 2, divide all of that by 2. That's going to end up giving us 3 pi times 2 over 2, which, no, that wouldn't actually. It would be the same thing as saying, 1/2. Okay, so it'd be 3 pi over 2 times 1/2. So that would give us 3 pi over 4. Okay, so we need to have a point above and below, so one above, one and below, from our origin, and it needs to be over to 3 pi over 4 units, which would be right here. So that one's going to be above, or one above, and this one's going to be one below. So that would be right here. So now our graph would look like this. And if we were to shrink this down, so if we were to shrink these dimensions down in either direction, it would end up looking like this, like on that scale. But since our scale here is basically from negative 2 pi to 2 pi, this is all we really have. All right, so let's look at 3. And hopefully I'm going to explain this more in class. It's kind of hard to do here on the video just because, I don't know, these graphs are a lot harder to do on videos because you can't actually see what I'm doing and I can't explain it as well. But we're going to go over it in class. I don't think I'm going to hang you out to dry. All right, number 3, 1/2 times tangent to theta. All right, so that number 1/2 in front is it's used for our amplitude and everything here, but this just pretty much means that that's like our guideline. So before, when we just had tangent and we were making kind of our 2 guide points, we would go like up 1 if there was no number there, like here. And then when there was on number 1, that meant we went up 2 and down 2. Essentially, this means we're going to go up 1/2 and down 1/2. So that's kind of what that number is here in the front. Now our period comes from this 2 that's in tangent with theta. And we take pi over 2. So then the period is just pi over 2. Now if we take pi, or that period, and divide it by 2, it will give us our asymptote. So here we would get pi over 4. Because if we divide by 2, essentially it's multiplying by 1/2, and that would give us pi over 2, or pi over 4. My bad. So our asymptote here is pi over 4. So anywhere we see pi over 4, which it's not written out here, but anything that would have a multiple of 4, or would have 4 as a denominator on the bottom, would work. So like here would be pi over 4. Here would be negative pi over 4. Here would be 3 pi over 4. And then here would be 3 pi over 4, negative 3 pi over 4, because it's right in between negative pi and negative pi over 2. So that would be 3/4 essentially. So those are all of our asymptotes. And I'm not going to make you do much more. You can kind of keep it simple here with these. Now, half of that asymptote is going to help us get our guide point. But we're only going above and below this origin. We're only going above and below 1/2. So this is actually kind of a weird one. Because we start here, and then we're going to go up 1/2 essentially. And if we cut this in half again, I guess it would be what? Oh goodness, what is 1? That'd be 1/8. So essentially we're going up 1/2 and over 1/8. So I don't know, it's going to look something like this. It doesn't have to be exact, but that's pretty much how that would look. And then your graph would look something like this. And then you would come over here to pi over 2, because our period was pi over 2, so that kind of gives us an indicator where we're going to start our next one. So we would start it there, and we would go up 1/2 and over like 1/8 essentially. So it'd be like right here maybe. I don't know. These are kind of a weird one. Actually, I did my second one bad. It'd be right there. So it would look like this. And then our last one would be over here at negative pi over 2. And then we would go up a half and over to like 1 over 8. And we would go down a half. And we do the same thing. So it looks similar. It looks kind of like that. So as long as yours looks similar to this, I'm not going to get as caught up on these like guide points really, or like where your points actually are. As long as they're in between this and they're not like as long as you didn't do this with like points here and try to do like that, I'm not going to mark off for it. So we'll do some more of these in class and go over these. And then for the homework, we'll probably do a couple of the homework problems together. So your homework's going to be doing sine, cosine, and tangent graphs. So we're going to do a bunch of those together just so you can understand how these are done.